Generation of action potential. So now we're talking about membrane potential. And again, this very basic definition I say it's like the electrical charge inside of cells. So what do? There are four general phases to an action potential. And what we notice is that, again, a resting cell or a resting neuron starts at negative 70 millivolts. So and it's inside a neuron at rest is more negative than its surrounding fluid. And then it starts to increase the membrane potential, crosses to 0, and now it's positive. So at this point, it has more positive charge than the surrounding. And then it becomes more and more negative again, and then this starts all over. I'll walk you through every single step. Okay, so action potential. So the thing is that once a resting cell's membrane potential, I'm just using this shorthand to make some room on the slide. Once it reaches a certain voltage, then these ion channels open and close, and then ions move in and out of a cell. Big changes in the membrane potential, so big changes in the electrical charge inside of a cell occur, and this is what we call action potential. So what we have, ion channels opening and closing, ions moving in and out of the cell, and because ions have charge, this causes the charge inside of a cell to change. So action potential, this is my definition I use. So it's a sequence of ion movements. Again, in this neuronal action potential, it's always the same channel. It's always the same channels opening and closing in the same sequence. Now, then we have to talk about a concept called threshold. So action potentials, these changes, these wide fluctuations, these increases when it gets more positive and negative and resets again, this doesn't actually occur spontaneously. It doesn't occur by itself. It only happens when an excitable cell, such as a neuron, reaches a certain membrane potential. So this is what we call a threshold. So this is the membrane potential you need to actually start an action potential. So a cell isn't going to just fire it randomly and do an action potential. They need to actually reach a certain peak. So I like to draw this analogy. Or actually, let's for this. So yeah, threshold. So in this figure, in the previous figure we saw, here the resting membrane potential at 70, and what you notice is that it gets positive and positive, more and more positive, and then it reaches something called a threshold right here. So this is the funny thing. I think the text might say negative 55 or something like that. I think OpenStack says negative 55, but this figure says negative 60. So whenever there's like a range like that, I just want you to know a general range. It's between 50 and 60. Go with 55 as kind of a good base. And then this sets off this action potential. So the action potential is actually this part here and here. So this big, like climb the roller coaster and then drop the roller coaster. So I like to think of threshold kind of like this. I like to do this analogy. So here we have a resting membrane potential, but if these snowboarders want to jump over this hill and do their tricks, what do they have to do? Can they just go halfway through? No, they actually have to cross here and then actually jump across, right? So this is why I think of the threshold. It's something you have to reach before you can actually do that action potential. So if you reach that threshold, then you can finally do that action potential. But if you're stuck down here, you're not going to do an action potential. So what if this snowboarder only goes this way? Are they going to be able to do that jump over the hill? Probably not, right? So same with the membrane potential and threshold. If a neuron or an excitable cell, like a muscle cell, does not reach its threshold, it's not going to be able to do its action potential. It's just going to, and over time, unless something pushes it all the way through the threshold, it's going to go back down to where it's resting. So what I'm getting at here, in order to do an action potential, you need to reach that threshold. No such thing as like partial credit for action potential. If you don't meet the threshold, you go back to where you started eventually. Okay, so then action potentials, they do not happen until a cell's membrane potential reaches a certain voltage. And this voltage and membrane potential is what we call a threshold. So this is the membrane potential. You need to actually do that action potential, that increase in membrane potential followed by a decrease. So Martini says negative 55 to negative 60, depending on if you're looking at the text or if you're looking at the figures, and OpenStax says negative 55. There are other texts and figures that say negative 50. Just know it's between negative 50 to negative 60. And if cell does not read, but the common thing, thresholds definition holds up. Even if though the value of a neuronal threshold varies between books, this definition holds true. If you don't reach the threshold, you don't get action potential. Your cell needs to reach that threshold to actually do that action potential. Okay, so I know lots of talking, lots of abstract stuff. Now let's get back to Top Hat. Oh, okay, so based on that value, if a neuron's membrane potential is negative 70 millivolts, will an action potential occur? Okay, let's see what the survey says. So looks like it's about like almost 1 to 3, and then what we have here. So yes, the action potential will not occur. Again, the threshold is between negative 50 and 60. Negative 70 is below that. So again, that's the resting potential. You don't get that action potential until you actually reach that threshold. Okay, so now the neuron's membrane potential has been pushed to negative 45. Will an action potential occur? Ooh, much more mixed this time. Okay, so which is the bigger number? Or which is greater, negative 45 or negative 70? So who is less in depth? The one that's in negative 45 or the one that's in negative 70? Yeah, negative 45 on the graph is greater than negative 70. So you have crossed that threshold, and action potential can occur. So even though you're still in the negatives, it is a greater number. So a neuron's membrane potential is negative 100 millivolts. Will an action potential occur? All right, so it looks like most of you said no, and most of you are correct. Again, negative 100, way below that threshold of negative 50 to negative 60. So you're further away from that threshold target. So it's like that snowboard rolled further downhill. So a neuron's membrane potential is 0 millivolts. Will an action potential occur? All right, let's see the responses. So most said yes, and most of you are correct. Again, it's like the threshold is negative 50 to 60. So even though it's 0, that's way above the threshold, so you can have an action potential. So again, you cross that, you're way past that negative 50, negative 60 millivolt threshold.